Hello and welcome to part 3 of the sequences and series topic. We're going to be looking at arithmetic series today. Before we get started, I've got a little puzzle for you. If we took all the numbers from 1 through to 100 and we added them all together, what's the total? If you'd like, pause the video and have a little go. See if you can figure it out in 30 seconds or a minute. Good luck. How did you go? Did you get the answer? The answer is 5,050. What's cool about this problem is that it's linked to a story about the mathematician Gauss. Carl Friedrich Gauss, that is. And the story is that when he was in primary school, the teacher set this problem, expecting the kids to take a while. As you'd expect, most students would probably go, okay, 1 plus 2 is 3, and then add another 3, that's 6, and then it would take a while. Gauss, as the story goes, solved it in minutes, very quickly. So how did he get to the answer of 5,050? Was it just because he was a smart cookie? Well, yeah, I guess he was a smart cookie, but did he have some other light bulb moment? So if you got the answer, what did you do? If you didn't get the answer, here's how we can approach this problem in a cool way. First, when we add two numbers together, the order doesn't matter. And this is called the commutative property of addition. So, if we take this commutative property and think about it with our question here, we can add the 1 and the 100 first, then the 2 and the 99, then the 3 and the 98, and so on. And each time we get the same thing. Each pair of additions will give us 101. So, how many of these parentheses or groups of 2 are there? Well, since there are 100 terms altogether, and we're splitting them into pairs, that means that there are 50 lots of 101, which is, you guessed it, 5,050. Pretty cool, hey? So, what's the link to arithmetic series? Well, in the last lesson we looked at arithmetic sequences, which is where we have some starting value, or some term 1 that we call A, and then as we go from one term to the next, there is always the same common difference, D. So the only difference here is that instead of a sequence, it is now a series, because we are adding all of the terms in the sequence. And so while this is an arithmetic series with A equals 1, D equals 1, and N equals 100, do you think we could apply the logic of solving this question to a more general arithmetic series? Well, that's what we're going to explore right now. So the first thing that we need to do is say, okay, how are we going to express this sum of an arithmetic series with n terms? Well, S for sum is pretty good, and it's of the first n terms. All right, now, our first term of an arithmetic series is A, and then our second term is going to be A, the first term, plus the common difference, D. And then we will have A plus 2D, and so on. So, at the back end of this sum, we're going to have our nth term, or our last term. So I might just write this here And instead of writing the nth term, Tn, as this, which we saw in the last lesson, we're just going to simplify things a bit and say that this nth term is the last term, L. And so what does that make the second last term if we're using L as the last term? What's the second last term going to be? Well, since the common difference is D, this is going to be D less than L. So the last term minus the common difference, D. And the third last term, well, that would be the last term minus 2D, right? And so now let's apply the commutative property that we talked about earlier, where we start to switch around the terms when we add them. So we have the first and the last term added together. Then let's do the second term, a plus d, added with the second last term, L minus D. Then we will do the third term, which is a plus 2D, added with the third last term, L minus 2D, and so on. What do you notice is happening? So this first lot of brackets we'll keep as a plus L, but what about this second lot of brackets? Well, we have A and we have L, and notice that we have D minus D, so they cancel, leaving us with simply A plus L. And this third lot of brackets, the same thing happens, except this time it's positive 2D cancelling with negative 2D. And if you compare this to our starting puzzle, remember we got 101 each time. We had 1 and 100, then we added 2 and 99, 3 and 98, and so on. So we always got the same thing. So now the question is, how many of these A plus L terms are there? Well, since there were n terms to begin with, and we have split these n terms into pairs, that means there are now n on 2 lots of these brackets containing the A plus L. So the next line, we can write that Sn is equal to n on 2 lots of A plus L. And that's the general formula for the sum of an arithmetic series with n terms. And if we wanted, we could go and replace the L with the nth term formula. So we could instead say, alright, we have n on 2 out the front still, and then we have A plus, remember L is the nth term, so that's A plus n minus 1 times D. So we have A plus A, so that's 2 lots of A, plus n minus 1 times D. So if we wanted to write it this way, we can do that as well. So let's do a few examples to finish off this video. Example 1. Evaluate 9 plus 14 plus 19 and so on all the way up to 224. So can we evaluate this sum? So we want to use the sum formula that we just came up with, which says the sum of n terms is n on 2 outside of A plus L. Or we can write this as the sum of n terms is n on 2 outside of 2a plus n minus 1 times d. Now, what do we know and what don't we know? Well, the a value, our first term, is 9. It's here. And d, our common difference, is 5. We can see we're going up by 5 each time. So that's pretty easy. Now we can also see that L, our last term, is 224. But no matter which of these formulas we go with, we need to know the value of n. And that's not readily apparent on first viewing. So what are we going to do? Well, this last term, or nth term, we know a formula for the nth term. Tn is equal to a plus n minus 1 times d. And here we know the nth term is 224, we know a, and we know d. So we have one equation and we can solve for n. So let's substitute in the values that we know. And now let's go through the process of solving. So we will subtract the 9 from both sides. So we have 215 on the left hand side. And on the right hand side, let's expand the brackets. We have 5n minus 5. So we have 5n equals 220. Now, last step is to divide through by 5. So we have n is equal to 44. Now that we know the value of n, and we can add that to our list, it's up to us to choose which of the formulas for the sum, which of these two, we would like to use. And since we know L and n now, this one on the left is probably a little bit simpler. The sum of the terms, and actually we know what n is now, don't we? N is 44. So the sum of the 44 terms is 44 on 2 multiplied by 9 plus the last term, 224. And when we compute all of this, we get 5,126. Now time for example 2. For what value of n is this series, 2 plus 11 plus 20 and so on, for what value of n is this equal to 618? Well, once again, let's start with what we do know. So we know that the starting value is 2. We know our common difference is 9 when we look at what we've got here. And we know what the sum, we want the sum to be equal to 618. So this is what we do know. We need to find the value of n. So if we use the formula for the sum that only involves a, d, and n, then we can solve for n. So writing this out. Now, hopefully you can see, okay, n occurs in 2 places. So we will have a little bit of rearranging to do, but because we know the sum value, we know the value of a, and we know the value of d, this is one equation with just one unknown. So let's substitute in our values. 618 equal to n on 2. 2 lots of a, that's 2 lots of 2, or 4, plus n minus 1 times d, which is 9. Now I've got a fraction here, okay, so personally I would like to multiply both sides by 2. So we're going to double 618, which is 1,250 1,236. And then we still have n out the front at the moment. Let's tidy up inside the bracket. So we've got 4 plus, and we'll expand this bit here. So we have 9n minus 9. Okay, now if we tidy this up, so 9n minus 5, but also let's multiply this n out the front. So we have 9n squared, right? 9n squared, and minus 5 times n. Giving ourselves a bit more room here. This is a quadratic. So let's set this quadratic, all the terms on the left hand side, and well, for now let's move the 1,236 over to this side. Okay, but then of course we can do a little switcheroo if you like. Now, looking at this quadratic, I personally don't notice any way of factorizing this very quickly. If you're good at knowing the factors of 1,236, go for it. So in this case, let's just use the quadratic formula. So we have n is equal to negative b, so that's 5, plus or minus the square root of b squared, that's going to be 25, minus 4 times a, 9, times c, which is negative 1,236. Okay, that whole thing's the discriminant, so that's all under the square root there. And then on the bottom of our fraction, we have 2 lots of a, or 2 lots of 9, so 18. Okay, now inside the brackets, when we work this out with a calculator, we get the square root of 44,521, and that's actually a perfect square number, which is very nice. So the square root of that is 211. So we get nice integer values. Now n must be a positive number, right? N refers to the terms. So we have the first term, the second term, and so on. So n is in the set of natural numbers, which means we can ignore the negative case. So let's just focus on the 5 plus 211 over 18 case. And so when we do that, we get 216 over 18, and when we work that out, we get a value of n equal to 12. And so we have found what we're after. We were asked what value of n makes our sum or our series equal to 618. So we've done example 2. Last example. The sixth term of an arithmetic sequence is 23, and the sum of the first 10 terms is 210. We need to find the sum of the first 20 terms. So this one's a little bit tricky because we don't know the value of a to begin with. We don't know the common difference, d. So we're going to have to work those out using the 2 bits of information that we've been given. If we can do that, and we know a and we know d, then we can go ahead and find the sum of the first 20 terms. Okay, so let's use our first bit of information, the 6th term. So term 6. Remember that any given term is a plus n minus 1 times d, and in this case n is 6. So 6 minus 1, or 5 times d. and this is equal to 23. So we have our first equation. The next bit of information is not the term, but rather the sum of the first 10 terms. So the sum of the first 10 terms. So we have n on 2, or 10 on 2, outside of 2a plus n minus 1. Now n is 10 in this case, so that's 9 times d. And so here is our second equation. We might just tidy this up a touch. Okay, so this is 5 out the front of 2a plus 9d, and we can then expand, so we have 10a plus 45d, and this sum is equal to 210. So there's our second equation. So two equations, 1 and 2, two unknowns, a and d. So let's solve simultaneously to figure out these values. In this case, I am going to rearrange equation 1 and make a the subject. So subtract 5d from both sides. Okay, and then let's sub that value. So sub a equals 23 minus 5d into the second equation. Okay, so into equation 2. So we have 10 lots of a, or 10 lots of 23 minus 5d, plus 45d, that's equal to 210. Expanding the brackets, we have 230 minus 50d plus 45d is equal to 210. And if we subtract the 210 from both sides, we get 20. And minus 50d plus 45d, well, that's minus 5d, and I'm going to plus that to both sides, so we get 5d over here on the right. Now we can see that d is equal to 4 when we divide through by 5, so d is equal to 4. And we know that a is equal to 23 minus 5 lots of d. And we've just figured out that d is 4, so we get 23 minus 20, so a is equal to 3. So we've figured out a, we've figured out d. We want to find ultimately the sum of the first 20 terms, so sum of the first 20 terms. And so we can say, alright, well, we have n on 2, or 20 on 2, outside of 2 lots of a, so 2 lots of a, plus n minus 1, okay, so 20 minus 1, times the common difference d, which is 4. So let's simplify 10 out the front, we have 6 plus 19 times 4. 19 times 4 is 76, and so 76 plus 6 gives us 82, and when we times that by 10 we get 820. So the sum of the first 20 terms is 820. And that finishes off our third and final example. Great job.